Okay, section 2.1. Basically, this section just contains review from just previous sections that we've done in this class. So we're just going to go over a couple of example problems, but most of these problems, they shouldn't be new. This is stuff we done in the first chapter. So for this first one, say we have some equation. F of x is equal to minus x squared plus 3x plus 1. And we want to find a couple of things. First, let's find what is f of 0. Well, f of 0 means we're just taking the 0 and we're plugging it in for x. So wherever we see an x, we're going to plug in the 0. And it's also nice to plug the 0 in. Whenever you plug it in with parentheses. So for example, we have our minus sign, but here's an x, so we're going to put a 0 there. Squared. And 3. Here's an x, so put a 0, and then plus 1. And then 0 squared is a 0, so that's going to go away, so we'll have 0. 3 times 0 is 0, so another 0, plus 1, and then that just equals 1. So the next thing we can do is, how about, say, f of minus a. So again, this is the same thought process as the last one, where we plugged in the 0 is wherever we saw an x, we plugged in the 0. So we plugged a 0 here, we plugged a 0 here. Now we have a minus a on the inside, so we're just going to plug a minus a in for all these x's. So we still have this minus sign. Here's our x, so that's where we're putting this piece in, minus a. Then there's the squared, so plus 3. So here's another x, so put a parentheses, and then we're placing this on the inside, the minus a, and then plus 1. So again, the same thing we did with this 0. Instead of plugging in 0, we're plugging in minus a. Okay, so what does this equal? Minus a squared, all you're doing is square. So when you square a negative, that goes away. So we're just going to have a squared. So this is just going to be minus. So this minus sign is this one right here. This minus sign goes away because we're squaring it. And then we have our a squared. So here's 3 times minus a, so that's minus 3a. And then plus 1. Okay, so and for the next one, let's do f of t plus 2. Again, so the same thing as last time. So just wherever whatever's inside this parenthesis here was a 0. We plug a 0 here, plugged a 0 here. But now we have a t plus 2 on the inside of these parentheses. So this is the thing that we're plugging in inside of f, this t plus 2. The t plus 2 goes here, and the t plus 2 goes here. So here's our minus sign, x, we put a parenthesis, and this thing goes on the inside, t plus 2. It's squared, so we put a square here, then plus 3. T plus 2 on the inside of these parentheses, and then plus 1. Okay, so now we want to simplify this. So the first thing we need to do is we have to simplify t plus 2 squared. So let's just do that off to the side. So t plus 2 squared, that's just the same thing as t plus 2 times t plus 2. So we're going to have t times t, which is t squared, t times 2, which is 2t, 2 times t again, which is 2t, and then 2 times 2 is 4. So this is going to be t squared plus 4t plus 4. Okay, so let's put that in right here. So we're going to have a minus, and this t plus 2 squared we saw a second ago, that's just this piece. So t squared plus 4t plus 4. Now here we have plus 3t plus 6. So just distributing the 3 across. And then plus 1. Okay, so now what do we get? We have a minus t squared, a minus 4t, minus 4, plus 3t, plus 6, plus 1. And so then if we combine all the like terms, we'll have a minus t squared. Here's a minus 4, so we'll have a minus t. Then minus 4 and 6 is 2, and then 2 plus 1 is 3. Okay, so on to the next problem. So for this next problem, we have another equation, just f of x equals x squared plus 4. Okay, now what we want to find is this, f of x plus h minus f of x all over h. So this is sort of just like a mixture of the last problem, just with a couple of more steps. So what we want to do here is we want to find what is f of x plus h, plug that in right here. F of x, we're given that, and then just divide it all by this thing h. So from this piece over here, the only thing we don't know is f of x plus h. So we're given f of x, that's just going to go right here. H we can think of as just like a number, so we're dividing everything by h, and then we're plugging f of x plus h up here. So first thing we need to do is find f of x plus h. Okay, so f of x plus h equals, and again, so remember just like last time, say if we wanted to do, f of 2, all we're doing is plugging in 2 for x. So this would be 2 squared plus 4. You get whatever's in the numbers on the inside, you replace for x. Now the inside is x plus h. So wherever we see an x, we're now going to plug in this x plus h. So here, wherever we saw a 2, we plugged in a 2 for the x. When we're plugging in 2, we see an x, we plug in a 2. Now we're plugging in x plus h, so we're going to replace this x. So inside these parentheses is going to be this x plus h. So we're going to have x plus h squared plus 4. Again, just plugging in x plus h for x. And now we need to FOIL this off onto the side. So x plus h, so we're going to get x squared plus xh plus xh plus h squared. And that's going to give us x squared plus 2xh plus h squared. So this piece right here, the x plus h squared, equals x squared plus 2xh plus h squared. Let's continue this down here. So we should write this off to the side. So we have f of x plus h equals this, which equals, and we just saw a second ago that this little piece, the x plus h squared, is this. So we're going to replace those two things. So x squared plus 2xh plus h squared. And we still have this plus 4. Okay, so we found we have everything we need. So here's f of x. Here's f of x plus h. So now we just got to plug these two things into this formula up here. So f of x plus h, that's this thing. So we have x squared plus 2xh plus h squared plus 4. Minus f of x, that's this thing. And this minus has to go to the entire thing. That's why I'm putting parentheses right here. It's minus f of x, so we're going to have to do minus this entire thing. And then all divided by h. And now let's just keep simplifying and see if things cancel. So we're going to have x squared plus 2xh plus h squared plus 4 minus x squared minus 4. Okay, so now things should cancel. For example, here's an x squared and a minus x squared, and here's a plus 4 and a minus 4. So all we have left is 2xh plus h squared all over h. But then one more thing we can cancel is you see on the top, this thing has an h and this thing has an h. So let's factor out the h. So we're going to have a 2x, and then we're taking out one of these h's, so there's going to be one h left over. And then the last thing we can do is cross out these h's. And so we get 2x plus h. Okay, so the last one, this isn't any different from something we did in the last section. So the only difference is, so we're finding the domain of something. Let's do two things. So we have f of x is, say, equal to 3x minus 7, and then f of x is equal to 1 over x squared plus 3x plus 2, and then we want to find the domain. The only reason this is a different problem than the one that we did in the previous section, you were just given like this, that we didn't say f of x. We just said find the domain of this without saying f of x equals, or find the domain of just this piece without f of x equals. But nothing changes. Just if we say f of x equals this and we want to find the domain, it's the same thing as finding the domain like from the previous section. So for example, for this first one, when we're finding the domain for a square root, we just have to set the inside of our square root bigger than or equal to 0. So we need 3x minus 7 to be bigger than or equal to 0. Because you remember when we have the domain for a square root, we can never have a negative on the inside. So the inside, which is just 3x minus 7, has to be bigger than or equal to 0. Then we start solving for x. We're going to get 3x is bigger than or equal to positive 7. And then divide by 3. X has to be bigger than or equal to 7 over 3. And then say if you want to put that onto a number line, here's 7 over 3. If it's bigger than or equal to, the or equal to thing means we have a closed dot, and bigger than means we shade to the right. So this is going to be 7 over 3 to infinity. And then for this one over here, so again, when we're finding a domain, we look, well, there's two things, remember? So fractions and square roots. This one doesn't have any square roots, so there's nothing like in this problem where we're setting things bigger than or equal to 0. But this one does have a fraction, and whenever we have a fraction, the bottom of the fraction can't be 0. So we have to figure out where is the bottom of this fraction going to be 0. So x squared plus 3x plus 2 is equal to 0. And we can factor this. This is going to be x plus 2, x plus 1. So we're going to get x is going to be minus 2, x is going to be minus 1. So these are the two x values that make the bottom of this fraction 0. So we go to our number line. Here's minus 2, here's minus 1. And because these two numbers make the bottom of this fraction 0, we can't be these numbers. So we're going to put a circle here, put a circle here, so we get rid of them. But then we're able to shade everything else. And the reason we can shade everything else is because these are the only two numbers that make the bottom of this fraction 0. And we only have a problem in two situations, with fractions and then square roots. So when we're finding the domain, these are the only two things that are going to give us an issue. So for example, when we have a square root, the inside of the square root has to be bigger than or equal to 0. So these are the only numbers that make the inside bigger than or equal to 0. But if there are no fractions, but there are no fractions in this problem, so there's no setting anything equal to 0, like in this problem. In this problem, there's no square roots, so there's no setting anything bigger than or equal to 0. So since there's no square roots, there's no issue with that, but there are fractions. This whole thing's a fraction. So we have to set the bottom of this fraction equal to 0, and then see what those x values are, and we have to get rid of those x values because they make the bottom of the fraction 0. So when we do that, get rid of these two numbers, and then everything else in here is going to be okay. So that's going to be part of the domain. So in an interval, it would be minus infinity to minus 2, and with a parenthesis in the 2 because we have the circle. Then minus 2 to minus 1, and then minus 1 to infinity.